Right, so hey guys, as he already introduced me, I'm Adrian. So today I'm going to talk about my journey of building a custom heat map system for Unity, especially, to pretty much analyze the effectiveness of level design. So a little bit of background about me. So who am I? Pretty much a mainly software engineer. I do a lot of web stuff, so front-end, back-end, APIs. I also do native apps, so mobile apps, Android, iOS. I'm also a game developer, so I'm mostly into like mechanics. I'm very into networking as well, and also being like a team leader from time to time in like game jams and things like that. Also, as he already said, I'm a University of Greenwich graduate in games design and development. And if you want to follow me, yeah, there's my Twitter, there's my GitHub. The things that I'm going to show today, maybe I'm gonna publish it on GitHub as an open source thing because I think it's a great tool that can be expanded maybe. But for now, I left it because it's quite like it was customly made for this specific project. So yeah, and this is a joke for whoever plays Hearthstone and knows the quote, "Who am I? None of your business." I don't know why John Cena is there, to be honest. I have no clue. So as an overview of what I'm going to show, so pretty much it's going to be like, it's going to show the importance of a heat map system inside pretty much any game, but mostly I'm going to focus on the 3D maze-like game. I'm going to show you how I've actually implemented, so what goes into doing that kind of system. And I'm going to analyze, I'm going to show you the analysis that I've made on this system on a specific game. So why is this tool important? Well, pretty much it informs level designers what goes wrong in a game level. So if, for example, someone gets stuck, you might know that if the level is too difficult, if the map has some problems, if some parts of the map are not explored enough or things like that. So I think it's a really useful tool to kind of improve over time, I guess, the feeling of a game, and the quality of a game. And I'm pretty sure like most of the companies use this kind of system to kind of improve that. So this is just my approach of building such tool. So why did I choose it to build it myself? Well, I just pretty much Googled any Unity analytics system on Google and found one which is made by Unity pretty much. But at the time when I built this, it was still in beta, and also it's a paid service, which I didn't want to do because, yeah, university stuff. Who pays for things? I'm a student. So pretty much I couldn't find any free solution for that, and I just decided, yeah, let's do it myself. Because I actually had an interest in data analysis for quite a while, so I said, yeah, let's give it a go. So pretty much I'm going to show like the infrastructure before I actually show you the tool. So how I thought about this, I thought, you have the Unity client. We're going to have some sort of a cloud API server, which is going to get the request and all that. And we have a database which is going to store the data that I'm going to record. So that's how it's kind of put into a 3-point layer. It could be more complex. Obviously, there's space for expansion. You could scale it to 100 machines and things like that. But I just preferred to keep it simple, just to do the job. So as you can see in the slide, pretty much I'm sending JSON to the Node.js. I have like 16 API endpoints for specific things like player position, if the player, I don't know, died, if the player left the game, and things like that. And then that server saves the data into the MySQL database. And whenever I need to see that data, it kind of calls the same server and pulls the data out. So because to test this tool, you obviously need a game. So I had to build a game which was a choice of, as I said, a 3D maze-like game, because that kind of proves my analysis on level design concepts. So maze-like kind of shows you if a player, pretty much proves the player's decision in specific scenarios. So the game is pretty much the player is put into a thief role, which was thrown into a dungeon, and he has to escape, and he has to find a key which is hidden in one of the chests across the dungeon. So obviously he needs to escape. That's the main objective. So I'm going to show you the main map layout of the game. and you'll see why this is relevant in a second. This game had 2 levels. So the level 1 was a more easier one because it was like more of an introductory level as well. So I did want to kind of show him some tutorials and things like that to the player. So this map, what is really interesting, and I'm going to show you here, is that you can see the way, hopefully you can see, right? The way I put the lights in here is like very like focused into a path, let's say. So it isn't pretty obvious that the player would get to these rooms, as you can see, because there's no like torches in here. So from a player perspective, you're going to see in a second, it's not that obvious that you can go in here. So I was wondering if I put the lights here, if the player would be driven to actually explore those rooms or not. So that's what I've done with the first level. I kind of tried to guide it in a one-way path to see if that actually works, if the players follow the pattern that I set up for this level. And you're going to see in a second if that actually happened or not. And this is the second level, which has, as you can see, the lights are spread more evenly. So it gives, in my mind, it was a design choice that it maybe gives the player more options to explore. So he feels like over a more open space area that he could find more things. So then again, as you can see, more lights spread evenly across all the floors. I'm going to show you very quickly. This is just to show you like what the game does. So the games had also like some sort of traps, so that they will give a player a challenge. So he'll have reasons to die. So as you can see, this was a gas trap, which kind of removed the health over time. This is a flame trap, which whenever the player gets in, he kind of gets hit by this. There's a boulder trap, which this was an interesting one because it's a very like surprise element. As you can see, the door over there just opened up and then it kills the player suddenly. So this one was very interesting to analyze if the player actually realized that the boulder was there or not. And a soul trap, which again, it is quite obvious, I guess, but yeah, maybe it has a surprise element in it, I don't know. And I had like these treasures, which again, this was an intentional design choice. So one of the chests is like just purely the model, no effects added into it. So if I play this, as you can see, it's just a normal chest that you can open. And the other ones were having actually some flashing lights and things like that. So I was wondering if players would notice the second one more than the first one, obviously. And that's just from a data perspective, not necessarily because some things are obvious. Like, I've made like an intentional stuck point to see if players actually get stuck into this area, and yeah, it was actually proven that I was right. And I had an end screen which kind of makes the player like in the data side of things, it's like he finished the session, so I know exactly if the players finished the game or not, or things like that. So pretty much the Heatmap preview system. So I have 6 different types of maps. So I have an overall map which shows pretty much all the ones underneath into one single map, so you can analyze everything at once. And I have specific ones, so like player path, to see exactly where the player went, and that is represented by colored heat maps. So you have different colors for how much the player stayed in one place. You have open chest map, which shows where the player, which chests in the level the player opened. Death points map, life loss map, and drop off points map. And a little preview of how that system actually works. So now I'm in the first level, just exploring around, opening a chest, and pretty much just wandering around. And afterwards, you'll see the heat map representation of the actual activity that the player did. I think it should be here. Hopefully, yeah. So as you can see, I'm choosing a username because it was like account-based. And then I choose a login session, and then I choose a game session because each time a player would start the level would generate a new login session. So as you can see, it goes into a very nice transition to a top-level view of the map. And as you can see, probably from there, it's exactly the same representation that you saw in the video, but like on a data kind of side of things. So you can see exactly the player went into that room, it opened up those chests, and then it exited the game at the end. I don't know if you noticed there's like a little red square as well, so in the beginning I stayed in one place for a while just to kind of show that, but it's very, very barely visible. So now, oops, I'm going to show you a demo of how that actually works. Hopefully it doesn't break, obviously. And I'm going to use a local one, just because I don't trust the Wi-Fi. So I hope this was one of the, nope. If not, I'm gonna just create a new account just for LUUG. I'm gonna call it LUUG. Yep. Okay, so I created an account. It automatically logged me in. Obviously, you have some tutorials and things like that. But the main thing in here is that obviously I can do exactly as you saw in the preview. I can walk around. I can open up chests. And I'm going to try to show you something different now. I'm going to go like upstairs because I haven't been upstairs. Because you can actually, in this Heatmap system, you can go through each level of each floor of the level, so you can transition from each of them. And in here you see I'm losing health over time, so hopefully you should be able to see that on the map. This was the final chest, so as you can see, it says that I got the key. And now I'm going to go into the second. Oh, actually, I'm going to stop here just to show that. So I can, as you saw in the preview, I can choose my new account, LUUG. I just have one login session, as you can see, and one game session. And if I click on the overall map, hopefully, if it doesn't break, as you can see, that was the path that I took right now. And I can transition from the first floor to the second one. And as you can see in here, hopefully, it's on red. It's not a good color scheme. Accessible. Change that. In here on red is like the marks where I've lost health over time. So as you can see, the player lost health in here, and this is very useful. Like, because I set up a challenge in the second level where the player had to go through a similar gas just to get to the end chest, and that shows you if the player loses health like a lot, and if the level is too difficult or not. And the orange box over there is the chest that I just opened. They might look like just boxes, but that's actually a model. Yeah, so this was the first level, and now the second level. Again, the same thing. And let's say I'm gonna die here. Hopefully, it should show up. Yeah, I died. Such a noob, I guess. And my own game. So now if I go again, as you can see, now I have another game session because I died, so it creates a new game session every time you die. So you can analyze it, obviously, in each section. So as you can see in here, marked with an X is the point that I died after I opened up the chest. And in this visualization is just more of like an overview, but obviously I have this data stored, and I have actually the reasons why the player died as well, which I'm going to show you right now. Oops. Sorry about that. Okay. So pretty much the test results. So because this was in a uni project, I had 23 accounts, which mostly were students and friends of mine who played the game. Thanks for everyone in this room who played that. So I've analyzed their data, obviously, after a nice gameplay. And I pretty much, out of the whole data, I figured that 17 out of 23 players finished the game completely. So some players actually dropped off. So that was the most interesting part because I could analyze why they dropped off. Again, the data offers me information like if the player were running or walking through the game. So that might show you a different type of player. It might be like an explorer or just like someone who really wants to finish the level as quickly as possible. So that was an interesting one as well. And this is just data gathered from the player's position. And the state of the player, if he's running or not. As you can see, the first level had a 100% chest discovery, so pretty much every player found each of the chests in the first level, whereas the second one was a bit more tricky, so because some of them dropped off as well, they couldn't manage to This is the empty chest. So that was the final. What I mean by final chest, maybe I got you confused there. The final chest is the one that has the key, who lets the player escape the dungeon. The empty chests, obviously, are the empty ones who doesn't have the key, and these were mostly the most interesting ones because they were the ones that I told you about, the flashing effects and placed like in specific areas that were intentionally. So as you can see, the second level, because I had so many lights in there, I got a 100% opening of empty chests. Whereas the first one, because I put the lights specifically to go to one direction, it was just 31%. These are the test results for the death reasons. So as you can see, mostly players died because of the gas trap that you saw, the one over time, because especially in the second level, because it was a bit of a challenge. So this is how you can use the data that I just gathered from the same visualization system. And this is the, let's say, the most interesting part, is where you actually analyze each player's walking pattern and see if the design choices work. So as you can see, this is the first level. As I explained to you before, I've made it intentionally to actually follow that pattern, as you saw. And this is the test result that I gathered from the players' gameplay. And as you can see, they pretty much follow the same pattern. Some didn't, like as you can see, like in here, the yellow point here means the drop-off point. But most of the players were actually following that pattern, which means my level design decisions were actually right. And in the second one, as you can see, it's a bit of a more spread pattern. So players were actually exploring more, trying new traps, seeing if they die or not. Yeah, I found it very, very interesting to analyze that. This is a funny one. I only had one player who actually got stuck into the intentional stuck point that I showed you before. This one was an unexpected one, because I didn't realize that my system could actually spot some map glitches. So pretty much one player actually fell through the map. I don't know how. One collider just messed up. And as you can see, you have a whole a whole data visualization of how he fell through the map. So I know exactly that happened on those stairs, and then he fell through, which is a very good. So this is a very good tool to test the map as well. So a bit about the performance. So as you can see, with just a single CPU server with 500 megabytes of RAM, so this is a cloud server. It was hosted on DigitalOcean. As you can see, it's not using that much, because I'm sending the data once every 5 kind of Unity units. I'm sending the data that I've recorded. So it's not. I've tried to optimize it as much as I could on the time frame that I have. I obviously did some data protection, so pretty much encryption and having a token for each player, and that token actually it's required to call the API request as well. So if you want to get any data from a database, you'll probably not be able to, because you don't have a token. That only happens from the game. And this whole data transaction was over HTTPS, so hopefully it should be secure enough, I guess. But nothing's secure enough, so I'm not gonna go into that. So yeah, any questions? That was my presentation.
I was super curious to see them all overlaid. Have you done that, like overlaying everyone's movements into one?
No, I don't have that representation. Okay, I know that was a feature that Daryl was requesting as well. That was a bit more complicated to do, because a lot of stuff I tried to do it, but a lot of the things were overlaying on top of each other. So I needed to create like some sort of algorithm which kind of knows how to calculate things. So those paths, for example, I needed to know exactly if I have like 5 or 10 points into the same area, it should like color differently. I didn't manage to do that in time, unfortunately, but it was on the plan. It was one of the things that like for future development, let's say.